next topic we're going to look at is determining and interpreting the slope of a line. The slope is a measure that tells how steep a line is. Slope is determined by computing the rise, meaning how far up or down you go, and you divide it by the run, how far left or right you go. Okay, so an illustration of this, draw a straight line that passes through the point 2, 1 with a slope of -3. So let's go ahead and draw our axes. Okay, and we're given the point 2, 1. Okay, so 2, 1 is here, approximately. And we're told that the slope is -3. So how can we use that slope in order to get some other points on our graph? Okay, well, we can use this rise over run definition. So the rise divided by the run, which is the slope, is equal to -3. But remember, any number can be written as itself divided by 1, because when you divide by 1, you're just left with the original value. So this means, since the run is positive, and the run represents the x direction going left and right, this means that we go 1 unit to the right. Then since the rise is negative, that means we go down. So we're going to go right 1 unit and down 3 units to get another point on the line. Okay, so starting at my point 2, 1, I want to go to the right 1 unit, which is going to take me to 3. And then I want to go down 3 units. So notice we're starting at 1. 1 minus 3 is -2. So we're going to end up at the point 3, -2. Okay, so let's try that again. So we're starting off with a point on our graph. Okay, so now we have 3, -2 is on the graph. Okay, let me just mark that off so we can see it a little bit better. So now we need to go to the right 1 space. So if we're starting at 3, we go to the right. That's going to put us at 4. And now we need to go down 3 units. So if we're starting at -2, we're going down 3 more units. -2 minus 3 is -5. All right, and that'll be the location of our next point, 4, -5. So you can continue going in that manner, but we actually have enough points to see what our straight line looks like roughly. So this would be a rough sketch of our line using the definition of slope, the rise over run interpretation. Well, we can actually determine the slope of a line. All we need to get the slope of a line are 2 points on the line. The slope is often represented by the letter M in mathematics. Suppose a line passes through the points x1, y1 and x2, y2. Then the slope of the line is M is equal to, well, to get the rise, we're going to do the change in y. So we'll have y2 minus y1. We're going to divide that by the change in x, x2 minus x1. Now notice when you find the slope, it does not matter which point you start with as long as you're consistent on the top and the bottom. So if you started with y1 and you did minus y2, on the bottom, as long as you start with x1 minus x2, you'll come up with the same correct answer. So in the next example, find the slope of the line that passes through the points -1, 4 and 2, -3. Sketch the line. Okay, so using our slope formula, it doesn't matter which point you start with, but just to make it look similar to our formula, why don't we let this be x1, y1, and we'll let our second point be x2, y2. So when we find our slope, we're going to start with -3 minus 4 divided by, then we're going to start with that same point on the bottom. So we'll have 2 minus, well, since my x1 is negative, that means I have to do minus a -1. So in the top, we end up with a -7 divided by 2 minus a negative means that's 2 plus 1, or 3. So I have a slope of -7/3. So my graph should be going down as I move from left to right, since we have a negative slope, like we saw with our example, our last example. Okay, so we just want to sketch our line, so I'm going to plot the point -1, 4. And notice I'm just going to estimate where that could be. And then we're going to plot the point 2, -3. Okay, and that would be a rough sketch of our line. Let's look at our next example. Find the slope of the line that passes through the points 5, 3 and 8, 3. So again, we label our x1, y1. You don't have to do this, but I know that for some folks this is helpful. Our x2, y2. And now we apply our formula. So our slope, represented by the letter m, is equal to y2, 3, minus y1, which is 3, divided by x2, which is 8, minus x1, which is 5. So we have 0 divided by 3, which is equal to 0. Okay, so let's plot these points and see what a line with a slope of 0 looks like. So we have the point 5, 3, and then we have 8, which will be here somewhere, 3. So notice they both have the same y value. So when we draw the line that goes between them, we see it's going to be a horizontal line. Okay, so with the same y value, you're going to end up with a slope of 0, which makes sense if you think about a ski slope. You think about something that's going to be climbing, something you can slide down. Well, if the slope is 0, it means it's flat, okay, which is what we have in this example. All right, in the next example, find the slope of the line that passes through the points 7, 4 and 7, -1. So again, put in our x1, y1, x2, y2, and our slope will equal -1 minus 4 divided by, then our x2 is 7 minus x1, which is also 7. So we end up with -5 divided by, well, 7 minus 7 is 0. Well, we cannot divide by 0. Dividing by 0 yields something that's undefined. So the slope of this line is undefined. So let's see, what does this line look like that has an undefined slope? Well, if I graph my point 7, 4, and then we have the same x value of 7, and then we go down to -1, we see that we end up with a vertical line that goes through 7 that has an undefined slope. Right, you can think about that as being ultimately steep because it's vertical. Okay, so that's an undefined slope. So in general, the slope of a horizontal line is 0. The slope of a vertical line is undefined. So make sure that you're very intentional when you say the value of something is 0. Don't say that it doesn't exist, there is no slope. 0 is a legitimate number. So a horizontal line has a slope of 0. A vertical line has a slope that is undefined.